I want people to realize that it's not a niche, that it is the way that chemistry should be done and that it should kind of pervade all areas of chemistry. My PhD advisor had a model river in the basement. She had a flume where she had sediments, and she was looking at the accumulation of chemicals from the sediments into the algae into snails. And this really clicked with what I enjoyed as a kid, being outdoors in nature and camping and all of these things, and it connected the chemistry and the biology. And I think when those two things clicked for me in research, that made me realize how important sustainability is to that closed loop cycle. A world that embraces green chemistry understands that the environmental implications and the environmental outcomes of chemical use and production are not divorced from chemical functionality. That if you want a certain function in a chemical, it has to be inherently included all of the implications of use of that chemical. Understanding how green chemistry could change things sometimes comes from a sense of frustration. Historically, how we have moved from one environmental problem, from one emerging chemical to another emerging chemical, that I realized that we weren't going to get anywhere using the same tools in the same way. And I think that really made me think about the power of green chemistry as a design tool. There's something in environmental chemistry that we call the lock-in problem. You have identified a chemical that does a super good job at something, and then you find out that it's also toxic. And often we get locked into the idea that it has to be a drop-in replacement. This is how we went from having BPA in baby bottles that was bad, and we replaced it with BPS, and lo and behold, BPS has many of the same problematic properties as BPA. And if instead you had moved to, say, a different material, you could have solved the problem without having this regrettable substitution. It may sound hyperbolic, but it's the future that's at stake. Every problematic chemical that we put out there, not only do they have hazardous properties, they're also extremely persistent. By releasing these things into the environment, we lock ourselves into a future where we're having to do cleanup, we're having to do remediation, we're dealing with health effects. Chemistry is incredibly powerful. I think that's why a lot of people get into chemistry, because they understand how we are working with the building blocks of the universe. Our ability to harness chemistry to make things that are truly sustainable, I can't think of a more powerful expression of that.